Welcome back to All This Math. This is Professor Parker, and make sure you are subscribed to the channel. Make sure you like this video. Also, if you have any questions or comments, please drop those down below in the comment section. All right, and also share this video with at least one other person. All right, so what are we doing today? Today we are factoring out a GCF. Of course, GCF stands for greatest common factor of this expression right here, right? Now, this expression looks a little different from the typical expressions that you'll see when your job is to factor out a GCF. Usually, you won't have like whole binomials within a term. So let's first understand this. This right here is a term. This is another term. This is another term. So this is a trinomial, right? It's different because, or I should say, rare, because part of one of the terms is in itself a binomial. So you got binomials inside of a trinomial. What's a trinomial? It's an expression with three terms. Terms are separated by plus signs or minus signs. So see, that's a minus sign and that's a minus sign. Therefore, this is a term, that's a term, and that's a term. So this together is one term, this together is another term, this together is a third term. But within those terms, you got binomials. That's what makes this problem a little difficult. Not more difficult, but just something you gotta think about because it's not typical. Like this might be a problem you might see like toward the end of the homework problems. You know what I'm saying? Right? This ain't nothing light. I mean, it is once I explain it to you, it's gonna be light, but just understand, right? You might see something like this. Now, you want to look for the greatest common factor of each of the three terms. All right. So first, what I always tell students, check your coefficients. In this case, the 14 is a coefficient, the negative 28 is a coefficient, and the negative 7 is a coefficient. So what I say is this. I say, ask yourself, what is the greatest common factor of those three numbers of 14, 28, and 7? And you could treat these like they're positives, you know what I'm saying, for the purposes of finding the GCF, right? So what I'm going to do is, and what I suggest you do is on your paper, write down GCF, and then figure out what's the GCF out of those three numbers. The GCF out of those three numbers is 7, because 7 is the biggest number that can multiply into 14, because 7 times 2 is 14. It can multiply into 28, because 7 times 4 is 28. It can multiply into 7, because 7 times 1 is 7. So the GCF is going to be 7, right? Now, look at these binomials. They should look familiar, right? They're all the same. That's an m plus 1, that's an m plus 1, that's an m plus 1. Now, what you do is you take normally, if this was a typical problem, this might be like an x, right? So it might be like x to the third, x to the second, or x to the first power because it's an invisible 1 when there's no exponent written. But it's not. It's a whole binomial, but the same rule still applies. They got the same expression, m plus 1, m plus 1, m plus 1. You take the m plus 1 with the smallest exponent. That would be this one right here, because that doesn't have an exponent written, which doesn't mean that it has an exponent of 0. It means the exponent is a 1. Whenever you got an expression or a term with no exponent written, that means the exponent is an invisible 1. Make sure you remember that. All right, so we're going to take this m plus 1 and put it next to the 7. So this right here, 7 times the quantity m plus 1, this is our GCF. This is our GCF. Now, when we want to factor this, we're going to write the GCF down. Like such, 7 times the quantity m plus 1. That's our GCF. Now, because this is such a long problem, a long expression, I'm going to use brackets. Now, what goes inside the brackets? What's going to go inside the brackets in this space, right, is the quotients you get. Quotient is what you get as a result of doing division, right? Just like you get a product when you multiply, right? The quotients you get when you divide each of these three terms from the trinomial by the GCF. So when I divide this by this, I get 2 times the quantity m plus 1 squared. Now, let me explain why. Let me make sure you know where that come from. Where does this 2 come from? 14 divided by 7. What is 14 divided by 7? It's 2. Where did the m plus 1 squared come from? Well, there's something called the exponent rule. Well, there's something called the exponent rules or exponent properties. One of them is the division property. The division property says when you divide a term by the same term, but the exponents are different, you subtract the exponents. Well, even if they was the same, you can subtract the exponents. So that's a 3, and that's an invisible 1. What's 3 minus 1? It's 2. That's where this 2 comes from. That's called the division property of exponents. Get familiar with that. Get real familiar with that. Now we're going to divide this by the GCF. You're going to have minus 4 times the quantity m plus 1. Now, where did that come from? Where'd that negative 4 come from? And this is what I suggest you do whenever you're doing any math problems, whether you're in Algebra 1, Algebra 2 class, a geometry class, pre-calculus, calculus, statistics. Make sure you know where every number came from. When you working the problem out, or when you're sitting in class looking at your teacher or your professor and they working the problem out, make sure you know where every number came from, every plus sign, minus sign, exponent, parentheses, whatever. Make sure you know where everything came from. And the moment you don't, that's when you got to do your job as a student and raise your hand and say, look, pardon me, excuse me, you know, honey bop, sweetie bop, don't mean to intercept, but where did that 5 come from? Where did that 3 come from? You know, you got to do your job as a student. So negative 28 divided by 7 equals negative 4. That's where that came from. M plus 1 squared divided by m plus 1 to the first power. No exponent, invisible exponent 1. 2 minus 1 is 1. That's why we got m plus 1 to the first power. Then we go to the last one. Last term divided by that, that's going to be minus 1. Why is it minus 1? Because it's the same exact thing. Anytime you divide something by itself, you get 1, even though this is negative and this is positive. A negative divided by positive is a negative. So instead of it being positive 1, it's negative 1. All right. So now that is the factored form with taking out a greatest common factor of this expression. Right. So now if I took more time to look at this, we might find that we could possibly factor this even further. But even if we could, I'm not going to take the time to look into that because that's beyond what we call the scope of this video. Because in this video, we just factoring out a GCF. That's all we doing. All right. So make sure you practice problems like these. Make sure you become familiar with problems that look like this, where your part of your GCF might be a whole binomial. You know what I'm saying? All right. And this brother I got on my t-shirt, this is the late W.E.B. Du Bois. Wrote many books. We should read them, right? Wrote a lot of articles for the Crisis newspaper, right? The literary arm of the NAACP back in the early 20th century. We should become familiar with a lot of his thoughts and ideas and a lot of his writing. All right, so practice this, study Du Bois. I'll see you on the next video.